Hello, welcome back to the radio room. Time to take a little further steps onto the SB220 amplifier we've worked on in some previous videos. And the reason why we're coming here now is we got something in the mail. And it's from Harbach. And all I got to do is find the end of the tape. Or maybe make an end of the tape. See if we can't get this opened up. This should be our brand new wafer switch. Get some light off of this, maybe you guys can see. Maybe a little more light. There we go. Our brand new wafer switch. All nice and shiny. We'll compare it to the old one, and then we'll see if we can't start putting a little work into getting it replaced. So first off, let's take a look at the old one, and we'll compare it to the new one. This one does have more lugs on it. It's designed so you can add some bands to it if you want to. Just need to get this the right direction. Let me get it out of the bag. Looks like it's going to be the right one. Alright, so let's compare this to our old one. Place this in here in the same configuration, just like that. Everything's looking pretty good. Just have to figure out which direction it's supposed to be. And what I'm looking at is where the rotor is lining up. Like I said, this one has extra ones on it, so I got to find the placement on which way it's going to go in there. Looks like it's going to be that way. We might leave that one off. That's probably for 160 if you wanted to add 160 meters to it. So let's see, that looks like it's going to work pretty good. I'll set this off to the side. I'm going to have to get this out of here. This is some pretty heavy duty wire in here. It's solid core. I'm going to go with probably 12 gauge solid wire. I'm going to reuse that. The geometry of them coming down should be pretty close, even on this wafer switch. We'll make sure that it's going to work all right. But I'm going to unsolder them from here and leave these ends alone, if at all possible. That way it kind of holds the geometry of the way these are and the distance off of this pad, so when I put it back in there, everything's going to be pretty close to where it's supposed to be, and won't have to bend things around and kind of reposition them in order to get everybody to line up. Because if you'll notice here, we got 1, 2, 3, 4 different spots external to these, that when it's sitting in there, it has to reach here. This one moves around a little bit, but we want it to be close to where it's going to connect to here. It's going to be a screw that grounds right there. And then these two for the mounting, which I still need to find some new hardware to mount that. We'll find something on that. One thing I will point out here, there's a lot of heavy duty right there. So I'm going to, and I've already unsoldered one of the legs that was on there. This was right here. And I'll have to clean that up. You can see that big gob of solder that stayed on there. I'll have to clean those up. And it'll give me a chance to get in here and clean these up a little bit better. But a lot of what I'm going to do here is soldering iron and solder sucker. Get in there, suck as much of that solder out of there as I can. And then I might have to kind of maybe use a little solder wick, get as much of it out. I might end up having to kind of walk these out just a little bit. I want to leave them pretty much in the same geometry they are, so that I can go back right back to where they were on the new one, and see if we can't get this thing out of here. I could, if I wanted to, go ahead and remove that, but I think I'm going to leave the wafer on this portion of the chassis right now. I'll get it up here in a good spot that I can work on it, because it's holding it, and it's holding it well. I don't want to be chasing this stuff around. There's going to be some solder, lots of solder that could be angles that I got to get to. I'll probably put a little pan underneath it. I don't know if you can tell right there. This black that I put on here a while back, it's pretty durable, but when I was taking this off, a big glob of solder fell right there, and tried melting through it. So I'm going to try and keep this a little bit in decent shape. I got some more if I have to change it, but that was a hot piece. I seen it drop. I probably waited 15-20 seconds to try and get it off of there, and I nearly burned myself. It was such a big glob that fell off of right here that it actually kind of melted that a little bit and trying to burn my fingers. So just wanted to start out with this right here, kind of tell you what we're going to do. Get all these off, get the new one positioned in the right spot, double check to make sure everything's lining up. It looks like if I put this in like this, I will be able to I have to make sure I get this the right direction here. Cannot be in the wrong spot. I'll make sure, and this might actually be the direction it needs to go in, right like that. Looks like it's actually in, and of course this is loose in here right now. But I got to key it. So you'll notice this shaft goes all the way through here and turns this too from the band knob up front. So I got to make sure everything is clocked right, so that when you're on the right band here, you end up on the right band here. So it's going to take a little bit of adjustment on that, but we'll get it figured out. I did already take some pictures of this. I wanted to make sure I got a good idea of the way everything was. The idea here is to replace this wafer switch, and as far as operation of the amplifier, nothing's going to be different. This is slightly different than the other one, but like I said, it's got extra band contacts on there if you wanted to add some bands for the amplifier. So I've taken some pictures, got everything kind of way everything's oriented and everything in case I have a question later. But in the meantime, I'm going to go ahead and see if I can't get this unsoldered, get these coils off of here, get this capacitor off of here, and then we'll see if we can't get the wafer off. So instead of just sitting here while I'm fighting with these, I'll go ahead and we'll be back in just a few seconds after I've gotten this off, or a good way. If anything comes up in the meantime, I'll put it on video. So I want to jump in here real quick and just show you. I found this interesting. Funny, I don't know. Take it how you want to. This one, like right here, has got a lot of solder on there. And I think the best way to show exactly how much solder is on here is to show you how much I pull off of there in one vacuuming of it. I want to get a little, tin my tip a little bit. And it gets soft and we'll suck it up. Now watch this. So that's just in that one time. There's been a couple of these I've pulled out and it comes out that far. Let me suck a little bit more off of there. This really Really just, I really do enjoy using a solder sucker like this on stuff like this, because it just, I mean, it just keeps coming. So I thought I would show that to y'all real quick. This thing is having no problem sucking it off of there because there's just so much to suck off of there. I mean, I'm literally I got something. I got tired of just putting it in, reaching down for the trash can. I just went and found something to dump the solder into. So let me get back to work on this, and we'll be back when I've either got this unsoldered or something else comes up. So I'm going along here, and I've decided the way the solder is acting here, I'm going to use what I call the walkout method. It's through there, so I'm actually heating this. Trying to. There's a lot of mass here to. I'm just pulling on it gently. And moving down to the next one. Definitely got to keep the soldering iron tinned up. Got the temperature up pretty good in order to do this. I'm going to move this one. I'll work back and forth. If I need to, I'll get my big gun out here on this. Really put some heat to this thing. Oh, that's trying. It's trying. Let me move down to this one again, see if I can pull this out just a little bit more. Really what I'm doing is I'm just working from one leg to the next. Trying to pull it out just a little bit. See, that one came out fairly decently. It's not all the way out yet, but let's see if I can get this one out of here. Okay, got that one to walk out a little bit further. I'm just slowly working it out. One leg at a time. For one, I'm not 100% concerned if I mess these up just a little bit. This is trash. It's going to get thrown away anyhow. So I'm just working these out. The concern I have is protecting the wire and the coil. That's the parts we're reusing. A lot of heat here. A lot of mass got to heat up. So I just wanted to show you, I'm just working these just a little bit. I'm only getting, you know, 1/8 of an inch maybe out on each pass or each step of doing this. Just slowly working it out of there. Gotta keep plenty on the soldering iron. I want all that heat transferring as quickly as possible I can to this leg in order to heat it up as quickly as possible because I'm actually going unsoldering 2 tabs at one time. Okay, that one's I've got that one out of one. I'm holding it here for a second because I don't want it to slide back in. It's basically soldering itself back in there. This one's being a problem. Oh, got my finger. This one I might actually have to get the big gun on. It just doesn't seem like I can get enough heat to it. Alright, so I'm going to continue working on this some more. We'll get this out here sooner or later. And we'll be right back when we got a little bit further. Alright, so I've gotten the coils unsoldered from the old wafer switch. Got the new wafer switch sitting here. And I figured out exactly which way it goes. And I'm going to set this on top of the control rod. It'll sit right like that. So here's going to be 80 meters, 40 meters, 20 meters, 15 meters, and 10 meters. I did want to point out, just I'll pull it up here in just a moment and we'll look at the schematic, that this switch doesn't necessarily have the output doesn't come into this wafer switch and then get selected to go through which coil it's going to go through. And I'll show you that here in just a moment on the schematic. This is more of a shorting bar, for lack of a better term. It just shortens this coil, basically. So let me get the schematic, and while we're looking at it right here real quick, I'll kind of show you what it's doing here and how it's actually working to make this assembly tune for the output of the amplifier. So give me just a moment. Okay, so I got the schematic up here, and the coils, or the switch that we're looking at on that wafer switch, is right here. I'm hoping y'all can see this fairly well. I might have to lift it up, get a little closer to the camera. Let's see if I can do this a little bit easier so y'all can see what's going on here. Okay, so right here we've got our 2 output tubes. Go through the parasitic filters, and the output comes here. It's got a blocking capacitor right there that keeps the DC. Remember, these plates right here have 3,000 volts on them when they're in the high power setting, about 2,500 when they're sitting at the quote-unquote low power setting. So this capacitor right here, all it's doing is blocking any of the 3,000 volt DC from going to the output. Because this is all the output. It's all heading for the output of the amplifier. It's right here. But capacitors will pass AC. So RF is AC. So the AC is what we're going to be concerned about. It's coming out here. This goes to the tuning capacitor on the front of the amplifier. There's a big knob on there that says tune. That's what that is right there. Connects to it, and it's just tuning between the signal and ground. Comes over here, and let me grab the coils here. And you guys can actually kind of see exactly what's going on with this, how this is doing this. This switch is working. So here's the coil. I'm having a little bit of a lighting problem here. The paper's too bright, but whoops, that didn't work, did it? Let me get some more light on here so you guys can see what a little bit better here. Okay. So this inductor, see if I can get the light right so you guys can read this without it totally washing out. Okay, so this inductor right here is this big coil. You can even see it's got a center tap on it right there. There's the center tap. So if you look at the schematic here, there's no input to here. Yes, you do have this here, but you also have it here, 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 and here. This switch, all it's doing is selecting how much of this total inductance is being used. For the lower frequencies, it needs more inductance. So if you come through here, the signal's wanting to come through here. It can't go, let's just start with 80 meters, with the most inductance. So it comes through here. As you can see right here, it's in the 80 meter configuration right now. You can see the rotor right here connecting this pin and this pin. Maybe, if you can see it through the washout. So it comes through this inductor, it keeps coming around here. Okay, it comes to another junction. Well, there's nothing connected there, so it keeps on going here. Nothing conducting there, and nothing here. So it goes through all of the inductance. If you move to 40 meters, which is right here, let me see if I can get this so you guys can really see it. Right there. Whoops, missed it. Trying to do this while looking at the monitor. Right there's the 40 meter contact. So when you rotate this around, you'll see it's going to lose contact here. It'll still have contact with the 80 meter. It's also going to be contacting the 40. Well, if you look, what is it happens when we connect these two together? It connects this line and this line together. So when the signal comes out and down through here, it's went through the first inductor, goes through the second, starts going into the second inductor, and when it gets to 40, right here, the signal can go up this way, and now these two are connected together and can come back out here. And it goes through here. But in essence, since these 2 points right here are shorted out through the wafer switch, this portion of the inductor doesn't do anything. It's easier just to go through here, come back, and go down. So that gets you 40 meters. When you move to 20 meters, the signal comes down, can't go there, it can't go there, those aren't connected to anything. Now, once I've rotated one notch further, now the 20, the 40, and the 80 pins, if you want to call them, contacts, are all shorted together. The signal comes down, it gains inductance here, starts gaining inductance here, but now it's easier for it to go up through here and go to these pins. Go down through here and still come down through this one. Now all of this has been shorted out. When you go to 15 meters, signal comes through this inductor, comes down. Whoop, now we got a short because I've rotated one more around here. Now this pin, this pin, this pin, and this pin are all shorted together. So it's easier for the signal to just go through here, through the wafer, and out back here. Some still going to maybe go through here, but this is a lot less impedance than this. So that's basically taking this entire inductor out of the equation. We're moving up in frequency, we need less inductance. So now this whole coil is the only inductance in the output. Let's go one more. We go to 10 meters. Now it's hooked to that center tap one. So the signal comes through here, goes through half of this coil, down to 10, this pin. All these are shorted out now, and it goes right down through here, and down. Now we don't have, this inductor isn't even working, and half of this inductor isn't even working. That's how they select the output inductance for the output of the amplifier. And of course right here is your load. The big knob on front says load. And it changes the capacitance at this point after the inductors to make to help tune it better for the output, 50 ohms output that you want on the output of the amplifier. So this doesn't necessarily have the power come in, then select which band it's going to go through and then back out. It's merely reducing the amount of inductors that are in line with the output merely by shorting them out. But as you can see, if you have a problem with one of these pins, say you're on 20 meters, well, remember I said it's easier for it to go this way. Well, if you have a bad connection right here, it's still going to try and go through there, and it's going to heat up that contact. So that's why you got to keep these clean. You want lowest amount of resistance here, nice clean contacts. If you start arcing here, because it's easier for it to go through a shorted bar than it is the inductor, these are going to start heating up, and when they heat up, 3,000 volts on them, might not be a lot of amperage, it's enough to cook it. And that's what happened on this one right here, the 20 meter I showed you in a previous video. It was totally blown up. 15 wasn't looking any better. So that's what's going on here. This half moon rotor just individually selects how much of the inductor is being shorted out to the other end of the inductance line. So just wanted to show you all that right there. I do have the kind of set the like I mentioned a moment ago, I did set the new wafer switch. This is just sitting on here. I haven't taken the old one off yet. I gotta get some more light here. Got confused on one of the lights I had on here. This, I just have this sitting on here. Got it lined up with where it's going to be. So this is the 80 meter configuration right here. It's not shorting out any of the inductance. This is the output side, I guess you could say, of the shorting. This will be 40, 20, 15, and 10. So if you can see, as you rotate this around, this is going to, in the next click, I guess you could say, of the band switch, now it's going to short this one and this one, which means it's going to take this portion. Let me get some more light on the subject here, and we'll take a better look at this. Starting at the bottom here. Remember, this was sitting like this. Don't mind the bumping of the camera. I just need to readjust it a little bit so we can see what we're doing here. Okay. So when you have the 80 meter connected together, it's basically connected. It does have a capacitor that sits right here that'll go to ground. Just add some capacitance into the 80 meter circuit. But it goes right through there. It's not connected to anything right here. See if I can get this up here so you guys can see it again without the washout. I've got to figure out my lighting a little better. That's a little better. On the 80 meter pin, it's just connecting, it's just adding some capacitance to it, because there's no way for it to come in here, but it does go through here and it goes through the load capacitor, and it can come up here and gain a little more once again, things are so bright that you can't see the paper. Let me see if this will work any better. So the signal comes through here on 80, and a little bit bleeds off just to capacitance, because it goes through here and it goes to this capacitor as well. So it's using the whole string of inductance. These are in series, basically. Once you go to 40 meters, with this wafer switch, it's going to connect this pin right here, and this pin right here together. And I'll go ahead and turn this so you can see what it's going to do. Normally, I'm turning the wafer. Obviously, it would be turning the rotor, not the whole thing. But now you can see these two are shorted out. Get this up here where you can see it. Now you can see these two are shorted out. Well, that shorts this one to this one, which basically takes this much of the coil, and it's not even used. We go to the next one. Now we've got 3 of them shorted out, so we're at 80, 40, now we're at 20 meters. It takes this one, and this one, shorts them together, makes this much of the coil no longer used. So it's just using this and this one coil. We go to here, 15 meters. So you guys can see that. So we've got 1, 2, 3, 4 of them shorted together. Hooks this one, this one, this one, and this one together. Trying to get that tab out of the way so you don't confuse it. But all these wires are now connected together, which takes, you can see this one goes up to here. This one's all the way down here. It bypasses the this whole inductor. So this isn't even being used. Now it's just using this portion. And once again, when you go to the last one, it connects from here to here, which takes half of this and all of this out of the inductance line. And if I could set the other part of the amp over here, I'd show you how that connects. I'll try to remember when I have this put back together how it's moving that to get to the output. But that's how it's getting into that. I'll try to show you on here. So you get to the output here, and we also have, so we have the load capacitor right there. That's just going straight to ground. But underneath here, I'd have to show you on the chassis, but there's another point right here where there's a coaxial cable that's hooking in to get all the way out. If you're wondering, well, where's it going after it gets to the last one, if this is just closed right here, the connection's actually underneath the chassis, just off of right here. There's this little guy right here. Remember that I talked about that I took off earlier and had the big glob that melted part of my desk? It's what's connecting to here. So this is connected in 2 ways right to there, which puts the capacitor in line, and also there's a coaxial cable that hooks to there to go down as well to get to the output. I'll try to remember to show you that when we have this a little more reassembled, but that's how the tuning output works on this, and how this is selecting how much inductance it needs. So I'm just going to rotate this back around to where we need to be to get everybody soldered on and make sure everybody's doing good. Oh, one more. So I'll connect 80 here, the 40 meter portion cut off on the inductor, the 20 meter cut off, the 15 meter cut off, and the 10 meter cut off, and of course reconnect that capacitor that's going to ground right here. So let me go ahead and see if I can't get this cleaned up. You can see those are still pretty rough looking. I need to make sure that they can fit through those tabs. They got to go through 2 tabs. You can see this right here. They got to go through both sides. There's a rotor on both sides of this. And the reason is it spreads that load, 3,000 volts, don't know how many amps, between 2 contacts and 2 rotors, so it's not all on just the one having to handle that much power through it. So let me go ahead and get to working on this. After I get this took off, I might go ahead and kind of slide this part out of here. This is the input side filtering switch. If you remember, there's a couple of broke off wires on there. I might slide this back, get in here, and get those resoldered as well. I will also have to make 2 new coaxes that come up to this. One coming from input, and the other one going out of here to the input of the tubes, the cathode side of the tubes. It runs up to the cathode side. In order to get this out of here, one was soldered up underneath here, which was really a pain to try and get to when this was sitting in the chassis, and there was no way to get it out. And then it has their grounds that connected to a little lug right here, which is right here. I've already taken it off. But in order to get that out of there, and the way it was going through the grommet, I couldn't get this unsoldered. I couldn't get this pulled up because the cable was catching on the grommet, so I cut the cable. It's RG58. I'll just make new cables, run them all the way to the input, and I'll take the one and run it to where it goes to the input of the cathodes for the tubes. But I'll probably get this out of here, get some room to kind of work in here without having to try and get behind stuff. We'll get the 20 meter hooked back up, and there's one more here. 15 meter. Nope. Yeah, 15 meter. Nope, 20. I'm getting myself confused now. It was the 20 and the 15, I believe, was the ones that aren't even hooked up. So we'll get those put up. Whichever ones it was the ones I showed you in the video before. I can see them right here. One's right here, and one's down there. I'll get that pulled out, get those resoldered, take a look at some of these, and hopefully we'll start kind of getting towards putting the amplifier together and getting it back to its owner so he can get to using it as well. Still got a little bit more cleaning to do on the chassis. I want to blow out the variable capacitors real good. So what I'm probably going to do is I'll go ahead and probably end this video right here. And when we come back in the next video, I'll have this put back together, at least this stage, and show you guys where it goes in and kind of how it hooks up. Probably be back on the phone for recording on that, because the amp just is not going to fit here. You can't even see my hands, and I'm making about how big the amp is. So that's about as far as you can see in the camera. But the amp would be right here. So that's not going to work very well over here. And there's no room to move it around over here. So I'll just use the phone to do the other recording. But let me get this new wafer switch soldered in. Need to get these leads cleaned up, get some old solder off of them, get some oxidation off of them, get them back into here, and fix the input filtering as well, the wires on it. And we'll see you at the next video, where hopefully it's all ready to go back in. We'll have some things cleaned up, and I'll show you kind of how things are going to go back into the amplifier. Because really, once we get past this, I make the cables that I'm going to have to connect to here as well. So I'll probably go ahead and do those. The manual tells me how long they need to be. I'll just cut them the same length, or I'll pull the rest of the other cables out and just make them the same length. And then I'll go ahead and have them soldered on here and ready to go. That way I can just slide them down through the grommet, wire them on the bottom side of the amplifier where they go, and it'll have brand new coax coming in for the input and going over to the input for the tubes. So we'll catch you next time. See you later.